Today we will study density index of soil or relative density of soil. Density index density density index density index of soil. Symbol is ID. Now relative density is a measure of compactness of cohesionless soil, gravel and sand. Density index is not applicable for the cohesive soil. Now ID density index is given by wide ratio in loosest state, that is Emax, minus wide ratio in natural state divided by Emax in loosest state and wide ratio in densest state. Wide ratio will be maximum when the soil is in loose condition, and it will be minimum when the soil is in densest condition. To determine the E maximum, loosest wide ratio and densest wide ratio E minimum densest wide ratio. The experiment procedure is given in IS 2720 part 14. With the help of part 14 procedure, we can find out E max and E minimum of soil. Now the value of ID will be 0 when natural soil is also having the wide ratio equal to the maximum wide ratio in the loosest state, and it will be ID will be 1 when wide ratio existing in the nature is minimum, means the soil is in densest state. So the value of density index will vary from 0 to 1. Density index value will be between index value will be between 0 to 1. Density index in terms of in terms of unit weight. We know that dry unit weight gamma D is specific gravity into unit weight of water divided by 1 plus wide ratio in natural state. When the soil will be in loose condition, then gamma D maximum will produce the minimum Y ratio G gamma W upon 1 plus E minimum. When Y ratio will be minimum, the dry density will be the maximum. Vice versa, when gamma D will be minimum, Y ratio will be maximum. Let us input this data into the density index formula E max minus E upon E max minus E minimum. E max will be G gamma W upon gamma D minimum minus 1 minus G gamma W upon gamma D minus 1 over G gamma W upon gamma D minimum minus 1 minus G gamma W gamma D maximum minus 1. Now taking G gamma W, this minus 1, this minus 1, this minus 1, this one will get cancelled. Now G gamma W, G gamma W, G gamma W taking in common. So this G gamma W, this G gamma W, this G gamma W, G gamma W will get cancelled. So remains will be 1 upon gamma D minimum minus 1 by gamma D upon 1 by gamma D minimum 1 minus gamma D max. Solving this, we get ID equal to gamma D max upon gamma D. Gamma D minus gamma minimum, gamma D minus gamma minimum divided by gamma maximum minus gamma minimum. So these two formulas will be very useful in solving a lot of problem of soil mechanics and the field problem. In the field, we find out the gamma minimum and gamma maximum of the soil in the loosest state and in the densest state, and what is the natural dry humidity weight is there. With that, we find out what is the relative density of the soil. Now, there is one table. After getting the values, we can find out what is the stage of soil when density index ID classification G, 0 to 15, then soil is in percentage. When it is 0 to 15%, soil is said to be very loose. No foundation can be kept on loose soil. When it is from 15 to 35, soil is said to be loose. and when it is 35 to 65%, then soil is said to be medium. When 65 to 85, soil is said to be dense, and above 85 means greater than 85, soil is said to be very dense. Now one more relationship is there, relative compaction. Relative compaction is gamma D in the field divided by gamma D determined in the length of the same soil. This is achieved and this is determined in the lab. So with this video, we learned today about the density index. It is a measure of looseness and denseness of soil with respect to the given soil. हम लोग उसको क्या कहते हैं, सॉइल को लूजेस्ट स्टेट में उसकी डेंसिटी डिटरमाइन करते हैं, डेंसेस्ट स्टेट में डिटरमाइन करते हैं, उसके बाद में